Hey everyone, welcome back to Math 1351. This is homework assignments for Chapter 12, Section 2, Additional Congruence Theorems. Okay, so first look at the first one. Draw each of the following figures using a protractor and measuring ruler, if possible. Complete parts A through C. Part A. A triangle with angles measures 60 and 70 and an included side of 8 inches. Okay, so we know that the left angle is 60, the right angle is 70. So that's possible. That's okay. This one can't be. So these two are out automatically because it's 70 and 60. And when we start with bottom left and go clockwise. So automatically these two are gone. So it's either A or B. And we said included of 8 inches. Included side means between two angles. So the first answer is A. So there's the first angle, second angle, it's included side, so it's between those two. The triangle with angles measures of 60 and 70 and a non-included side of 8 centimeters on the side of the 60-degree angle. Alright, so again, we have to have, since 60 comes first, 70, that's okay. This one's no good, so we can't use that. We can't use that. Because 70 and 60 are back. Now, it also says that the non-included side, that means this 8 centimeters is not between the 60 and 70, it's on the side of the 60 degrees. That can't be it, because that's, who knows if that's the angle or whatever. So, it has to be this one. So it's on the side of the 60, so that's on the side of the 70. So it has to be D. Because it's, the 80 is on the side of the 60, the 8 centimeters on the side of the 60. A triangle with angles measures of 30, 70, and 80. So the ones we cannot have. That can't be 80 degrees, because 80 degrees is much bigger, so that one can't be right. 70 cents that one. So it has to be one of these two. So we start at 30 degrees, we go to 70, and then 80. In that order, clockwise. So it has to be this one. It's from 30 degrees, 70, and 80. Alright. So far so good. I hope. Alright, each of the following conditions, is it possible to construct two non-congruent triangles? There's two triangles that don't have the same size and same angles. Explain why or why not. So the first one. A triangle with angles measuring 60 and 70 degrees and it included 8 centimeters. It's not possible because the two triangles of these conditions are angle, side. No, but remember it's included, so the first one would be, we have 60, this 8 inches, and 70, so it's angle, side, angle. So it's angle, side, angle. B, a triangle with angles measuring 60 and 70 and a non-included side of 8 centimeters on the side of the 60. Let's see. So we have 60 degrees, 70 degrees, and 8 centimeters on the side of the 60. It's not possible because two triangles of these conditions, angle, side, angle, nope. That side is not between the two angles, so that's not right. Side, we only have one side, so that's not right. Angle, side, so it's got to be C. And the last one, C. A triangle with angle measures 30, 70, 80. 30, 70, 80. As we said, sorry, another picture. Well, since these angles are already given, there's not much we can do. It has to be non-congruent. It is possible because given conditions, the unique shape, but not size. So it's not one of those. It's not the side, angle, side. It doesn't have angle, angle, angle anywhere, so It's this one. It could be, we can have two of them. Actually, this is 80, 70, 30. Number 3. Determine whether the conditions angle Q is congruent to angle N, angle R is congruent to angle O, and segment PQ is congruent to MN are sufficient to prove that triangle. Okay, we have two triangles. P, Q, R, that's the first one. M, N, O. So we know angle Q and angle N are congruent. That's true. R and O, those are also congruent. That's true. PQ is MN. Is it enough to justify it? Yes. How can we do that? Well, we have two angles and a side, so it's angle, angle, side. Number 4. Determine whether the triangles are congruent. If so, name the postulate or theorem that justifies it. Are they congruent or not? So A, the triangles are congruent, the angle, side, angle. Yeah, but we don't know about the lengths of the sides. If they were congruent sides, this would be line, this would be line, double line. So we can't really use that. Side, 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 again, same thing. We don't know anything about the lengths of the sides. Don't ever trust a picture the way it looks. It has to be labeled. If two sides are equal, then they'd have to have the labels like that. So the triangle is not necessarily congruent, not enough information. The triangle is congruent by side, angle, side. No, we don't side. So we don't know enough information about that because all it tells us is these two angles. Yes, side angle, but angle, angle, angle. There is no angle, angle, angle. We have an angle, side angle, but it doesn't tell us about the sides. There's one angle, one graph could look like this, one graph could look like this. It could be bigger. So there's not enough information. Number 5. In each of the following, fill in the word that's needed. Okay, this one here, we have to know what each of these pictures look like. And I went ahead and created this for y'all. What is a square? A square has all 4 sides of the same length, they have the same length, and all 4 angles are the same angles, all 90 degrees. A rectangle, all internal angles, these are the angles inside the picture. They're all right angles, they're all 90 degrees, but opposite sides are parallel, are the same length, congruent. Opposite parallel sides are congruent. In a square, all 4 sides are congruent, all the same lengths. In a parallelogram, you have opposite sides are equal, but opposite internal angles are congruent, are equal. Unlike the parallelogram, where all 4 sides are right, all 4 internal angles are right angles, 90 degrees, this one, only the opposites are equal. That's a parallelogram. A rhombus, you have opposite internal angles are equal, and all 4 sides are same length. It's like a square that's been squashed. A trapezoid. Now, 2 sides are parallel. You have the top and the bottom, but they're different lengths. And the angles cannot be equal. That's all we can say. So, all we know is trapezoid is two sides are parallel. an isosceles trapezoid. Two sides are parallel, and the adjacent internal angles are congruent. So, since these two sides are parallel, those angles are equal, these angles are equal. These two sides are parallel, these sides are same length. That's an isosceles trapezoid. So if you take a square and push in the sides towards the top. A kite. Two pair of adjacent sides. Here's a side, it's adjacent to that angle. They're next to each other. So two pairs of adjacent sides are equal length. And the shape also has an axis of symmetry, meaning that you can either fold it along the middle, and it has opposite sides that are congruent angles. Again, we all know what a kite looks like. An irregular quadrilateral. No sides are equal in length, and no internal angles are the same. So anything that looks weird, that's an irregular quadrilateral. Okay, we'll need to know that to do this. So, number 5. Fill in the blank. A quadrilateral is a blank if and only if its diagonals are perpendicular and bisect each other. Its diagonals. In other words, from that corner to that corner, that corner. So those are diagonals. So now, the diagonals are perpendicular and bisect each other. Are those perpendicular? Well, possibly. But do they create a right triangle? Do those? No. How about a parallelogram? So if we drew diagonals there, are they right angles? They bisect them. The only one we know for sure is the rhombus, because of the way it's shaped. It kind of looks like a kite. Because if you notice in a kite, it creates a right triangle. So that's perpendicular. We know that for a fact. The difference between a rhombus and a kite is a kite has one side that's longer out. So this one here, the first answer is a rhombus. And the second one, a quadrilateral is a blank if and only if its diagonals bisect each other. If and only if its diagonals bisect. In other words, bisect mean complete. It cuts it in the middle. Well, we know automatically that the rhombus does, but this is the difference is its diagonals are perpendicular and bisect. All this one wants is bisect. And what we saw earlier, the only one that does that is a parallelogram. It creates a right triangle. Yeah, so I'm going to include this sheet with all the angles on it, the pictures on it for you guys. Okay, last one. Classify each of the following as true or false. If all sides of a quadrilateral are congruent, the quadrilateral is a rhombus. If all sides of a quadrilateral are congruent, they're all the same sides. So that's not it. That's not it. So far, it's either a square or a rhombus. So, if all four sides are congruent, then it's rhombus. True. It's not the only one. A square is the same thing, but it's just said, is it a rhombus? It could be a rhombus, yes. In the statement A, if a rhombus is a square, it must also be a rectangle. True or false? Now let's do the definition of a rectangle. Four internal right angles If it's a square, it's a rectangle. Opposite sides are equal length. Opposite sides are equal length. So it's true. So if a rhombus is a square, then a square is a rectangle, then a rhombus is a square. So it's true. So if rhombus is a square, we know a square is a rectangle with equal sides, therefore a rhombus is a rectangle. All right, that's it for that one. Good luck, everybody.